Starting section 1.4 of chapter 1, we're going to look at some basic rules of algebra. So again, we need a few more vocabulary so that you can follow and understand what the directions are saying. I'm not going to quiz you on the vocabulary. I'm not going to ask you to write out definitions, but you will need to understand what they mean. And in a test situation, if you say, I don't know what the directions are saying, what does this word mean? I'm not going to be able to help you on that part because that's what I'm testing for, is to see that you understand and know these. Okay, so let's look at what are terms. Terms are the pieces of an expression. Remember, an expression is anything that's letters or numbers hooked together with any kind of operation. Adding, subtracting, multiplying, divided. But there's no equal sign, so that's what an expression is. So terms are the pieces of an expression that are separated by a plus sign. Okay, that's how you know what is a term. So if we had 3x plus 5 as our expression, then the terms of that would be 3x and 5. 3x would be one term, 5 would be another. There would be two terms to that expression. If we had the expression 2x minus 4y, notice the definition says they're separated by a plus. Here's another thing I want you to start understanding. The relationships between mathematics will go a long way for you to being able to do math on your own and be able to accomplish what you want to in this class in terms of learning and knowledge in your grade. One of those concepts that's critical and key is to understand that subtraction is really just adding the opposite of what you were doing. Instead of and some of you were taught this from the beginning, and that's great. But this is the same as saying 2x plus a negative 4y, and really apply that negative there. Okay, so then our two terms, that plus sign tells us we have two terms here. So really I should make this an equal. These two equal each other. 2x minus 4y equals 2x plus negative 4y. There are two terms here. One of them is 2x, one of them is the negative 4y. Okay. Very important that you attach those negatives to those terms. It will really help you out when we get further along in 1665. Let's look at what a coefficient is. It is going to be the number that's in front of the variable in a term. Or it's the number part of the term. When you have a variable and a number together in one term, the number part is called the coefficient. The variable is the letter that represents the number we don't know. The coefficient is the number in front of the variable of the term. So let's go back to our example here of 3x. The coefficient is equal to 3. Okay, let's go back to our example of 2x minus 4y, which I want you to think of it as 2x plus a negative 4y. There's two coefficients here. The coefficients of the first term is 2. 2 is in front of the x. The coefficient of the second term is a negative 4. Sorry, I got a little squish there. That says the coefficients of the first term is 2 and of the second term is negative 4. They're the numbers in front of the variables. That's what coefficients are. So then what is the constant term? The constant term is any standalone number, no variable. So it's a standalone number, no variables. In our original 3x plus 5 expression that we've been looking at the whole time, the standalone number, the constant there, is 5. And our pink example, 2x minus 4y, which I want you to start thinking of that as 2x plus a negative 4y. That will really benefit you. There is no constant in that one. Both terms have variables in them. So there's no standalone numbers. let's look at what factors of a term are. They're the pieces of a term that are multiplied together. So if we had, let's switch to a fresh example here. If we had 8w, we know that if 8w is our expression, we know that 8w is equal to 8 times w, so we can see that the factors are going to be 8 and w. We don't know what w is, but we know it's being multiplied together with 8, and so that makes it a factor. And also, if you wanted to get really technical, which we will be breaking down numbers when we need to, you could say that not only are 8 and w factors, but anything that goes into 8 would be a factor as well. So 2 and 4 are also factors that would go into 8. So 2, 4, 8, and w. But if you were, the reason why I'm just mentioning that is this is what you're going to need for now, just splitting it up, 8 and w. As we move towards 65 factoring, you're going to want to see that 8 really has some different components as well. But for now, just understand that factors are what gets multiplied together to make our answer. To make our term, I should say. Okay, so like terms, let's look at what that is. Like terms are terms with exactly, and I can't emphasize this enough, exactly the same variable. And that includes exponents. So if we have 17x plus a negative 4x, those would be considered like terms. We'd be able to go ahead and combine those like terms. So this one, because we have an x and an x, they exactly match. So yes, these are like terms. But what are some examples where they wouldn't be like terms? Let's say you had 17x plus 7y. One variable is an x, one variable is a y. They are different variables altogether, so no, not like terms. What if you had 17x plus 7? Okay. Again, do they have exactly matching variables? No. It's tempting to go, oh, well, we'll just add 7 and make that 24. Do not. You need to rid yourself of that temptation. You need to practice, practice, practice so that that doesn't even tempt you at all. You don't even think of trying that, because 7 does not have a variable. It's just a constant. Constant terms cannot be combined with terms that have variables. Okay, and I would love to interact in class with you about why that is. Okay, so let's see if you can remember to. So if you want to know why, ask in class on that one, because that would be a fun interaction to look at. Well, fun for somebody like me who really enjoys mathematics, and you never know, you might like it too. There's no variable here, so this is not like terms. You'll notice I added in the explanation, this includes exponents. So let's look at one more example. Sorry about that. 17x plus 17x squared. Sure, they both have x and x. Actually, I didn't really want it to be 17. I just wanted to be plain old 7. 17x plus 7x squared. So you've got an x and an x, but this one over here is x squared. Okay, as soon as we know the value for x, we're going to be squaring it, which means that the value for x is 2. It would be 2 over here, but it's worth 4 over here. That makes these values very different, because 2 times 2 is 4. So, no, these are not like terms. All right, and that gets us to some examples at the bottom of the page.